Welcome back to Boiler Bytes. Can you imagine what it'd be like to actually touch an asteroid floating in space? Imagine mining that asteroid for precious elements. Well, it turns out that Purdue's Aeronautics 418 undergraduate class was recently selected by NASA to help develop an asteroid chipping tool for that very mission.
Well, I'd been active with the education group at NASA Johnson Space Flight Center in Houston since about '96 when they had started to run a student zero gravity flight experiment program, an annual program. It was late December of 14 that the news came out. For a new piece of hardware, invented, designed, and built by students to be ready for testing. Right away I started talking to some undergrads who I thought would be interested.
And over winter break, he emailed me and asked me if I would like to be a team lead for this upcoming project that NASA had sent him information about. The asteroid chipping tool that an astronaut can use in a microgravity, zero gravity environment to chip samples from an asteroid, as NASA's looking to, sometime in the near future, send manned missions to the asteroid belt or to nearby asteroids as to further expand human space exploration.
We'll start by sending astronauts to an asteroid for the first time in history.
None of us in aerospace are field geologists who go out and sample rocks. The students and I went out and talked to a number of people with this type of experience.
We had to design a tool that could cover a wide variety of materials. Some asteroids are just, held together by gravity, and it's no more than the consistency of dust or powder. Other asteroids have a much denser construction.
So it became clear that there had to be some interchangeable tip to do, undisturbed or uncontaminated sampling.
In the first 2 weeks, we had to submit a proposal by the end of January. 2 weeks go by and we hear back from them that our proposal is accepted. From there, it's build your item.
There was quite a bit of custom fabrication work. Some of them did that in machine shops. Some of it we shopped out to other shops and producers.
The chisel is just screwed in to the containment unit, and then the containment cap closes at the very end. So at the end of the test, our samples can be contained and prevent any cross-contamination. The other subcomponent we had is the air hammer. With a custom-made forcing hammer part, it locks into place like this, and it's good to go. It's pretty easy. It just simply sits down right on the cap, and it's ready to be used.
Our students, I think, they have this innate curiosity, this innate creativity. And some of the students do more, three-dimensional computer design. Some of them do more structural safety. Some of them do more operations work. And so my role is really kind of guiding proper communications with the NASA sponsors. And then in June, they were down in Houston testing it with the astronauts and engineers.
NASA's Neutral Buoyancy Lab in Houston, Texas. You walk in and you can't see much at the beginning because you walk into it's a dry dock, and you just see this giant wall, and that's the pool. That's what's holding it, holding all the water in. And then they eventually take you up to the control room to see, and when you're up there, it's just massive. I can't think of any better word to describe it. But when it comes down to it, we have to hand it over to the divers to use our tool. And just taking the divers step by step through the process, take out the air hammer, place the containment unit on the rock, attach the air hammer, and then pull the trigger, check to see if it's there, and just doing it step by step as they would through any spacewalk. It's more or less if you think about just a hammer and chisel that any archaeologist would use.
If you would like to attempt another chipping at that site, you may proceed.
Okay. Place the containment over. Placing drill.
We also had help from our Professor David Wolf, a retired astronaut, Purdue alum, and really an expert in EVA, extravehicular activity, or spacewalking.
Just being able to work with someone with his experience doing EVAs to really guide our design in terms of the ergonomics, things that we wouldn't be able to really know without his assistance, was absolutely fantastic. NASA actually had some of their own personnel kind of doing their own design on the same challenge that we were working on. And when we showed them ours, they got really excited because their design actually looked very similar to ours that they had come up with. But there were certain things that they hadn't thought of, like the flexible rubber billows at the bottom, just to help form to the surface and make the awkward angles easier to reach. So just knowing that like our ideas are something that they can carry forward on, that was absolutely fantastic and just a really neat overall experience.
That was great to hear, that was great to see, and I think it shows some of the value of this type of program to NASA. It's not simply encouraging STEM education and awareness of spaceflight needs, but it's broadening the amount of brain power and background they can bring to bear on certain topics.
One of the things the reasons I came to Purdue is just the opportunities that they have to participate in these kind of projects, especially in the AE department with Dr. Collicott's Zero Gravity Flight Experiment. There's a long and rich history of doing these types of experiments, whether it's on the Vomit Comet or the new projects down at NASA's Neutral Buoyancy Lab.
We have about a dozen different payloads, projects underway right now in the class. Some are completed and awaiting launch with commercial suborbital companies. Purdue has been very supportive of this, my department heads and deans over the years, and a lot of hardware funding. Donors have provided a lot of student travel money.
Learning from the people that are in the field, that are the experts, that are, it's NASA. I mean, it carries that name recognition. And just seeing that there's so many different types of careers out there that I can apply my experience in aeronautical engineering too.
This is my 20th year of this type of hands-on design, build, test, real-world application teaching. It's an immersion. It's a real-life engineering education experience, and so I think they get a lot of things in that area. I think many of them achieve more than they dreamt that they could. It's exciting for me to teach, and it's unlike anything I think they can find in most other schools.
Outstanding job, you guys.
Thank you.
That wraps up another Boiler Bytes. Check us out online at boilerbytes.com. See you next time.